Chemistry Kangaroos, Miss DeAngelis here to talk to you about counting atoms. This is actually the second part of our series, and I'm going to discuss with you how we figure out how many molecules we have of different atoms, different compounds, how many elements do we have in each chemical formula. So let's actually get into it. And I know from math, you guys have studied coefficients and subscripts, and you know they are not the same. So the coefficient is the number that is in the front of the formula, and that's going to tell us how many molecules we have of the atoms that we have in this group. And guys, the subscript is that little number right here. That's a number that's at the bottom of the element, and it tells you how many of that particular atom of that element we have. Now remember, if you don't see anything next to the element, it is implied that there is just one of them. So we can say that we have 2 hydrogen and we have 1 oxygen. X, Y, G, E, N. Okay. What is a coefficient? It's the large number at the beginning of the formula. It tells you how many molecules are present. So in 2H2O, it means that there's 2 molecules of water. And the number that's in the front, this coefficient, gets applied to everything that is in that formula. So if we were to draw it out, and I really encourage you to do it because this way it gives you big picture, you can see that we have 2 water molecules. We have 2 H2Os. So in reality, if I were to break this down, I would say I have 4 hydrogen and I have 2 oxygen. Because when I do the math, 2 times the 2 here is 4, and 2 times the 1 that's here is going to be 2. So the total number of atoms that I have is 6. Okay, the subscript only gets applied to the element that it follows. But remember, guys, we did have an example where that was the subscript was outside the parentheses. I'll get into that at the very end of the problem. I'll show you how to apply that one if you don't know how to do it already. So again, if there's no subscript, you assume that there is only 1 atom of that element in the molecule. So in 1 H2O molecule, there are 2 hydrogen atoms and 1 oxygen atom. So how many hydrogen atoms are present in the above molecule? So we know that when you multiply the 2 times 2, we get 4. And you know that when we multiply 2 times the 1 that we know exists there, because we only have 1 oxygen, we get 2. So how to count the atoms? So this is a strategy that I generally use. I want you to write down all the symbols for the elements that are present first in the formula. That means that tell me how many elements that we have. Look at the capital letters. The number of capital letters is going to tell you the number of elements that are present. Go ahead and look at your periodic table. Try to match up. Like if you saw capital H, you would look at your periodic table and say, oh, H, it's hydrogen. If there is a coefficient, write this number next to each of the symbols. So for example, 2H2O, if we go back here, I would say that I have 2H2 and I have 2O2. So that's how I would write that out. That's what I mean by saying, oops, sorry guys. If there is a coefficient, write this number next to each of the symbols. Okay, now multiply the coefficient by the subscripts of each of the elements present in the formula, and that's what I did so that I was able to get the 4 and the 2. Okay, so let's try this one together. So I have already looked at the capital letters. So I know that I have 3 because I have a capital C here for calcium, a capital C here for carbon, and a capital O here for oxygen. So if I looked at how many calcium I have, it is 4, because I'm looking at this 4 here. The subscript after this A is going to be 1, so I know that I have 4 calcium. Then I'm going to apply the 4, and I'm going to multiply it times the 1 that I know exists with the carbon. So that's another 4. And then look, there's a subscript here with the oxygen, and the value is 3. I know that if I apply the 4 times that 3, I'm going to end up with 12. So that's how you figure out how many atoms you have in your chemical formula. So again, if I went and I wrote the coefficient, I would write 4 next to each one. I would then go ahead and figure out what the subscripts are for each of them. And then these are the answers that I would get, and my total is going to be 20 atoms. Okay, so let's try this one. So I know that we have 3C, and I know that I have 3O2. Okay, so I'm going to say this is definitely 3 carbon. And I'm going to have 3 times 2, which is 6. So I'm going to have 6 oxygen, which is a total of 9 atoms. Now I'm going to break this one down. So let's say I know that I have C for carbon, I have H for hydrogen, and I have O for oxygen. So I'm going to say C, and I'm going to put an H, and I'm going to put an O. So now I know that I'm going to take my coefficient, which is here, and I'm going to apply it to each of my elements, because each of the elements is going to be multiplied by that coefficient. Okay, so I have 2C. What is my subscript? I have a 6 for the carbon, I have 12 for the hydrogen, and I have another 6 for my oxygen. If I do my multiplication, I say 2 times 6 is 12. 2 times 12 is 24, and 2 times 6 is 12. So I add these all up, and I get 48 atoms. So if I add all of these up, I would get 48 total atoms in 2 molecules of glucose. Okay, this is a doozy. This is a challenge. So what do we say first? So first, we know that we have to break it out with the coefficient, but let's first see how many elements we have. Be, we have P, and we have O. So let's see, we're going to say Be. First of all, you know what? Let me go ahead and rewrite this formula using that subscript, because that may actually make it easier. So I'm going to say 2Be, and then I'm going to apply the 2 that's on the outside, because remember your rule of PEMDAS, you always apply what's on the outside of the parentheses first. And I'm going to say P has 2, and I'm going to say my O has 8. Okay, and I know all of this is now going to be applied by the coefficient. So if I separate it out, I'm going to say 2Be3, 2P2, and 2O8. Okay, that should start simplifying things at this point. So I'm going to say that I have 6 beryllium. I have 4 phosphorus, and I have 16 oxygen, for a grand total of 26. I have 26 atoms. Okay, the law of conservation of mass. So the law of conservation of mass states that mass cannot be created or destroyed, but it can move and it can change. So that's important here, guys, because we are not destroying atoms. So again, the law of conservation of mass states that mass cannot be created or destroyed. So just for you to be aware, for you to understand that, that concept. Okay, guys, go ahead, finish your Edpuzzle. After that, fill out your Google form. And if you have any questions, I will see you on the other side. Bye.